Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to learn how to organize our level data. Now, usually I like to organize levels as multi-dimensional arrays, essentially creating a tile-based structure. With a space shooter though, we may want to have a bit more fine-grained control over our level layout. So I'm going to share with you a hybrid approach that I've come up with that allows for fine-grained pixel-perfect positioning on a micro level, while still allowing us to have a tile-based layout on a macro level. So let's get started. We'll start up our project and open it up in Sublime. The first thing I want to do is create a folder called Levels. I'm going to be organizing our level data into multiple files, so I'm going to keep them all in one folder and put an index in that folder so that we can still include it with just one require. Now I'm going to start off with a familiar data structure that you would have seen in the previous lessons where we created a tile-based puzzle game. We have an array of objects, and each object represents a level. We have a name, and we have our level data here, which is a two-dimensional array, where each element in the array represents a different game object. Now I still want to keep this for our sort of macro level view of our space level. But our character can move quite fast, so he's going to traverse any small amount of space quite quickly. So I'm going to imagine that each of these little elements here is actually an area of our map that is 500 pixels by 500 pixels. So if we think about it like that, we can put in the cell width and cell height that each of these elements represents. But if we're not going to put individual game elements into each of these, then what are we putting in there? Well, it's quite common in space shooter games to have waves of enemies. In your standard side-scrolling shooter, you'll often encounter the same formation of enemies more than once. These waves of enemies often make up part of the game mechanic. The player can get used to the waves and become better at defeating them. Then just as they're getting used to it and they let their guard down, you can throw a different wave at them, or maybe a more advanced version of the one they already faced. So into each of these zones, we're going to be placing a wave of enemies. So let's create one of those waves. We'll create a new file, call it wave_a.js. So what does our wave look like? Well, we're going to be exporting an object. This particular wave is going to be filled with meteors, because at the moment that's the only enemy or obstacle that we have. But you could obviously have as many different classes as you want, and mix and match them. We can give our wave a name, Meteor Wave A, and now we can create the data of the wave. So each wave consists of an array, which has all of the objects we want to instantiate for this wave. Each object will have an object class, in this case Meteor, and then some arguments. Each meteor will be instantiated with an X position, a Y position, and a size. We then give it an array of arguments. Our X position for this one will be 30, the Y is 30, and the size is 0. Now at the moment we haven't actually set up the meteor class to handle different sizes. This is something I can let you guys do on your own. But basically we could fill out a wave by creating a bunch of different meteors with different positions and sizes. And that could be our wave A. We can change the internal data here to make a wave B. We'll save this as wave B. We're also going to need a zone that is our home base. This obviously needs to contain the hero, but it could contain many other things such as power-ups or some kind of recharging station, whatever you like. So we require our hero, give it a name of home base, and create the data where we put our hero in the middle of our zone or quadrant. Remember, each of our zones is 500 by 500, so the hero will be in the middle here. I'll just save that as home.js and go back to our index. So what does that change now here? Well, firstly, we need to include our three waves. I've included them all with single character variable names, A, B, and H, so that I don't break the layout of my macro level map here. And then I can quite simply populate my space map with different waves of baddies. Notice that not every single one has a wave of enemies in it, because we want our hero to be able to explore a little before running into bad guys. We can tack on a second level like this. In this particular version, the hero is surrounded by waves of bad guys. If we go back to our main file, we can use this level data to create our world. Firstly, you'll need to load in the levels module using require and come down here to prepare world. Let's pull the creation of the stage out of that function and pop it up here. We only need to do that once, but we'll need to load levels and prepare the world essentially many times. So remove all of this. Before we were adding in our hero and our meteors specifically by hand. Now we're going to be doing it using the level array as data. So the first thing we need to do is get the particular level that we're working on. We'll get our level by going to levels, current level. Now remember when we set the extent of our world size, we did it just by hand here, by hard coding a value in here. This is the world width and height. We don't want to do that anymore. We actually want to get our world width and height from our level data. So to get the world height, we need to multiply the cell height by the number of arrays that we have in our level data. Then the world width is the cell width multiplied by the length of the first array. So now we're going to have to create a two-dimensional loop to navigate our two-dimensional array. So level.data.forEach, and for each iteration we will get a row of cells and we'll have a row index. This is basically the index, but if I name it row index, we'll be able to understand exactly what we're dealing with. Then for each of those rows, we're going to iterate and get a cell, and we'll get the cell index. So if there is a cell, that means that the cell doesn't just equal 0. We can console log what we're building, the cell name, and we'll need to get an X and Y offset. Remember that let's say we're in this cell here. When we're placing all of the objects from this wave, we need to add to them an X and Y offset so that they're placed in the correct position in the overall space. So the X and Y offset is basically the cell index multiplied by the level cell width and the row index multiplied by the cell height. So now that we're down at the cell level and we know we have a cell, we can now otherwise assume that our cell is an object with a data array. So let's iterate that data array. Cell.data for each, and for each one we're going to get an item. We'll set C, capital C, as our item class, and then we basically have to instantiate that class along with the arguments that were passed here in args. Now to dynamically instantiate a new instance of a class while passing in an array of arguments is no easy feat. It takes a little bit of wrangling and you have to do some things that may seem a bit strange. So firstly, to the arguments we have to concatenate. We have to add the class itself to the beginning of the arguments array. So we're going to create a new array with C, the object class, as the single item. Then we're going to concatenate item.args to the end of that. So we'll now have an array that has C and then X, Y, and size. Next, to get our instance, we have to do the following. We're going to wrap a little bit of JavaScript in parentheses so that it gets executed in its own sort of closure. And we're going to call c.bind.apply and pass in C as the context. This essentially gets ignored. And then the arguments. So what is this doing? Well, we're getting the bind method, which usually returns a new function bound with a specific context. And because we need to pass in an array of arguments, we're calling apply on bind. So this is going to return a new bound function applied with these arguments, all wrapped up in these parentheses, which we can then call using new. And hey presto, we have our new instance. So we can set the instance x to instance x plus x offset, and the same with y. Then we will add that instance to the world. Now we'll still need some reference to the hero, so if our class equals hero, then we'll set hero, which is our module level variable, to instance. And there we have it. Let's go to localhost 9001 and see if it works. I've forgotten to set current level. Back here we can set current level equals 0. Now it says cannot read property canvas of undefined. So there must be something else. Now that I'm no longer returning anything in prepare world, I'll just delete this so it doesn't overwrite with undefined. And here we go. If you see down here, we've built all of our waves and we can go exploring and looking for those waves of asteroids. Whoa, just ran into one there. We can shoot them. There's another wave here. And we can keep on exploring until we reach the confines of our map, which is now a dynamic value. If I change current level to 1, we can see our other level layout. Now in terms of changing the level, for instance when the player has destroyed all of the asteroids, I'm going to leave that to you guys. We've already learnt about that in a previous lesson, when we were building our tile-based game, so I'm sure you can apply the same knowledge to this game. Well, that's all for this lesson. Check back in for the next lesson where we're going to look at sprite map animation. Ciao!